Okay, so in this problem we're going to look at a problem involving probabilities, independent events, or in this case non-independent events, and tree diagrams. So we're going to work out this problem here. Basically what we've got here is we got a bag with 5 red beads and we've got 4 green beads in the bag. So we have a total of 9 beads. Okay, so someone comes along, they take out 3 of the beads, one after the other, and they don't replace any of the beads. The first question we want to know is find the probability that all 3 are red. So they pick out 3 red beads in a row. Second question is find the probability that one of the beads is red and the other 2 are green. Okay, so let's have a look at working this problem out. We'll just look at question 1 first, part 1. So part 1 here, we want the probability that all 3 of these beads are red. Now we know that when we add these two here, we're going to have 9 beads in total. So our probabilities here are going to be out of 9 initially anyway. So to take, the person takes a bead out of the bag, and we want the first one to be red. So there are 5 red beads, so the probability that the first bead that he takes out, or that she takes out, is going to be red is going to be 5 out of 9. And the second bead has to be red. So and is, we're going to multiply here. Now, with this kind of probability here, you have to assume that the first event has happened. So in other words, the first pick was actually a red bead. So a red bead has been taken out. So in other words, we're only left with 4 red beads. And because a bead has been taken out and hasn't been replaced, we've only got 8 left. So the probability of getting a red bead on the second pick is 4 out of 8. So now we have a third pick, so and again we multiply here. This time we assume that these two have occurred, so we have taken out a red bead, we have taken out a red bead, so there are only 3 red beads left. And also because we've taken 2 beads out, there are only 7 beads in total left, so it's 3 out of 7. So this is our probability here that the 3 beads were red. So we've got a total then of 60 out of 504, which just simplifies to 5 over 42. So this is the probability here that all 3 beads that we pick out are red. Okay, so that's question 1 done. Let's have a look at question 2. Now, in this particular case, I'm going to use a tree diagram to work out this probability here. So I'll just give myself some room here. We want the probability that 1 is red and 2 green. So we want 1 red, 2 green. So I'm just going to draw a tree diagram here first to represent what's actually happening here. So we're going to start here, we're going to go here and here. This is our first pick here. So what can happen? We can either get a red bead or we can get a green bead. Okay, so we're going red or green. Now, if we picked a red bead first, on our second pick, we still can pick a red or a green bead here. If we picked a green bead first, we can still pick a red or a green bead here. So this would be our second pick here. Now we picked 3 times, so we're going to go again. So we're going to go red and green again, red and green again here, red and green again here, and same here, red and green. So if we look at this is a typical kind of a tree diagram here. So I'm just going to write out all the outcomes here. So all our outcomes here are, we could have gone red, red, red. So we'll just change the color here. Let's say our outcomes are red, red, and red. We could have gone red, red, green. So red, red, green. We could have gone up here red, green, red, red, green, red. We could have gone up here red, then down to green, then over here to green. So that's R, G, and green here. So we've done all of these, this particular arm here, we've done all of these. So now go down along here. So we could have gone green, red, red. So we go green, red, red here. We could have gone green, red, green. Green, red, green. We could have gone green, green, red. Green, green, red. And we could have gone green, green, green. So these are all our possible outcomes. This is our sample space here. We couldn't have, there are no other outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8 outcomes here. Okay, so now I'm just going to fill out the probabilities on each one of these branches of this tree diagram here. Now, just to recap, we had initially, let's see, we had 5 red beads and 4 green beads. So we'd 5 red initially, and so we'd 5 red, and we had, what did I say, 4 green. So we had 4 green beads here. So we had 4 green beads, so 9 in total. That gives us a total of 9. So let's have a look here. The first pick, this is our first pick here. So this is our first pick. This is our second pick here. And this is our third pick here. First pick, second pick, third pick here. Okay, so let's have a look at the probabilities here. I'll fill in all of these probabilities along here. Now, on our first pick here, what was the probability of picking a red? Well, we had 5 reds out of 9, so our probability here will be 5 over 9. What's the probability of picking a green the first time? Well, we had 4 greens, so our probability here would be 4 out of 9. Now, if we go up along here, we picked a red. What's the probability of picking another red? Now, we've removed one of these reds. Remember, we're not replacing these beads. So we've removed one of the reds. So now we only have 4 reds left, and we also only have 8 beads in total. So our probability here would be 4 out of 8. What about down along here then? If we picked a red, we still have 4 greens. So we have 4 greens, but we only have 8 beads left here, so our probability is 4 out of 8 here. If we went this way, if we picked a green out, first of all, what's our probability of picking a red here? Well, we haven't affected the number of reds. Reds are still 5, so it would be 5, but we have affected the total number was 9. It's now going to be 8 because we haven't replaced the bead. So if we go down along this way, we picked a green. So there's a green missing here, so we're down to 3. So we only have 3 greens left, and also there are only 8 beads left, so it's 3 out of 8 here. Okay, so let's have a look up along these arms here now, our third pick. Well, let's work our way up along here. We picked a red, so we picked out 2 reds, so there are only 3 reds left. So we've only 3 left here, and we picked 2 beads out, so there are only 7 left in this case, so we can put a 7 here. So 3 out of 7 here. If we picked a red, and now we go down to green here, well, we picked out 2 reds, doesn't affect the greens, so we still have 4 greens here, so that's going to be 4 over, but we have reduced the total number by 2, so we're still down to 7 here. Okay, so let's move down to this arm here. So we've picked out a red and a green. What's the probability of picking a red? Well, we've picked a red and a green, so we've removed one of the reds, so we have 4 left, but we've removed 2 beads in total, so we're still down to 7 here. In fact, all of these will be over 7, so we just have to work out how many of these colors are left. So we've gone red, green, so we picked out a red and a green, so we have affected the greens, so we picked 1 green out here. So that's gone down to 3. So this will be 3 over 7 here. If we go this way, then we've got a green and a red. So we've removed one of the reds. So we have 4 left. So here we will be, let's see, 4 again over 7 because we removed 2 beads. What about this one here then? Well, this is green, red, and now we want green. We've removed one of the greens, so we've 3 left, so this would be 3 over 7. So now the last two then, okay, so we've got a green, green, red. We've taken out 2 greens, doesn't affect the reds. We still have 5 reds here. So this would be 5, but we have taken 2 beads out, so we still only have 7 left. Now we have taken out a green and a green, so we've taken out 2 greens, which only leaves us with 2 left, 2 greens left, and since we've taken 2 out, we have 7 left. So these are all our probabilities placed on all of the arms. So you can see that these events are not independent. What we do in our first pick will affect what we do in our second pick, which will affect what we do in our third pick here. Okay, so now we have all our probabilities. Installed here on our tree diagram. So what were we asked? We were asked here, what is the probability of 1 red and 2 green? 1 red and 2 green. So let's have a look at the different outcomes here. So we want 1 red and 2 green. So we want 1 red and 2 green. Here's 1 red and 2 green. So we're going to look at this one. 1 red and 2 green. Here's another one here. 1 red, 2 green. Here's another one here. We've got 1 red and 2 green. And that's it. We have 3. Is there another one there? 1, 2, 3. 1 red and 2 green. No, that's it. We have 3 of them here. So let's put these 3 sets of probabilities together. So let's have a look at that. Okay. So let's look at this branch here. How did we get to to this particular outcome here? Well, it's here, here, and here. So we went up red, up to this red here, down to this green, and then down to this green. So we want a red and a green and a green. So that would be 5/9 and, which is times, 4/8, 4 over 8, and we're here now, we want to go down to here, and 3/7, 3 over 7. So this is one probability here. So if we do that, you multiply 3 by 4 by 5 and 7 by 8 by 9, and you end up with 60 over 504. So that's the probability of getting down to this outcome here. Now we do exactly the same for here and here. So let's do this one first. Green, red, green. So we had to come down here, then we had to go up here, then we had to come down here. So it's 4 over 9, 4 over 9, and 5 over 8, and 3 over 7. 3 over 7 here. So when you multiply those 3 together, you get 60 over 504 as well. 60 over 504 here. So that's this one here. Now we'll do this one. So again, we're going to go down here, we go down to this green, and then we go up to this red here. So what are our probabilities? So we can, to pick this green here is 4/9, and then we must come down to this green here, which is 3/8, and then we have to go up to this red here, which is 5/7. So when you do that, you also get 60 over 504. So these are our 3 possibilities here. So we can go along this branch here to get a red, green, green, or we can go down along this branch here to get a green, red, green, or we can go down along this branch here, these branches here, and we could have gotten a green, green, red. So it's this probability or this probability or this probability, and we know that or in probability means you add, so we're going to add this fraction to this fraction to this fraction here. So what we effectively end up doing is just taking 60, 60 over 504 plus 60 over 504 plus 60 over 504, and when you add those together you get 180 divided by 504, and if you simplify that you get 5 over 14. So in other words, the probability, if we pick 3 beads from the bag, don't replace them, the probability of getting 2 greens and a red is 5 over 14.